Hey folks, welcome back to Mears Lab. I'm Thomas Mears, and in this video, I'd like to have a close look at this really neat Paia Model 4700 analog monophonic modular synthesizer. Let's get started by having a look at the left side of the case over here. There are three oscillators. These are the Model 4720 oscillators. And let's see what the features are here. So it's got four different waveforms. It's got the sawtooth, and it's got a triangle wave, it's got a sine wave, and it's also got, of course, the old classic square wave over here as well. Just below those, we've got a couple of knobs here, and this one is just to set the sort of like the standard pitch of the oscillator. There is no coarse and fine adjustment. You've just got this one knob right here, and it's got a really super wide range on it. Later on, we'll have a look at the keyboard, but the keyboard also has another pitch adjustment on it as well, too. So you can kind of get almost like a coarse and fine thing going on there. Anyways, right below that, we've got the control inputs for the pitch right here. So something interesting to note about these oscillators is the outputs here, they don't just send a constant tone out. It needs to have some sort of like a control voltage sent into here. You know, like something from the sequencer over here, or maybe from the keyboard down there, or whatever, you know. But you won't get any audio out of this until you plug some sort of control voltage into the input right here. And let's see here. Right beside that, we've got the square wave, and it's basically just the pulse width adjustment right here. And then you can modulate that right through these control voltage inputs over here. And of course, you can modulate the pitch as well too, like from the LFO over on that side of the synthesizer. Pretty cool. And we've got three oscillators all together, and all three of them work really well. I will say one thing about this synth is it is an old synthesizer. I'm pretty sure this one's all the way from 1976. I'm the second owner, and I got it from the first owner, who is a friend of mine, and he bought it brand new and built it all the way back in the day back then. Anyways, back in the day, I gotta say, I don't think that pitch was the stability and scaling of pitch was nearly as good as it used to be, or as it is nowadays, I should say, because I would say that these oscillators can probably track pretty accurately over like 1 octave, but I'd say like over 2 or 3 octaves, like, yeah, the pitch just does not track very accurately. It could just be the way that I have them calibrated. I actually found the calibration a little tricky to wrap my head around in the manual. So maybe somebody else out there have better luck than me with it. But yeah, just something worth noting about those oscillators. They certainly have a lot of that vintage character that folks really like about synthesizers. I'll definitely say that. They do have a really wide range. They go down to really low frequencies, and they go up pretty high as well too. I don't know the specs right offhand, but the manual is out there, and it's got the specs in it. So once again, this is the Model 4720, and yeah, let's move on to what else is in here. So right over here is a really cool module. This is the 4712 Reverb module, and it's a spring reverb. Yeah, there actually is a spring reverb tank right in the back of the synthesizer here. Once we'll take these modules out later, and then we'll see it. It's right behind there, screwed into the back of the synth, and it's a super great sounding reverb. It's not a super long time. It's not super short. It's like a medium reverb length, and it just sounds really, really nice. It's so cool to have a spring reverb in a synthesizer. So cool. All right, looking down here in the bottom left corner is the 4780 sequencer. It's a 12-step sequencer, and it's pretty cool. This one works really well. There is just one little issue with it. It's got, well, one of the LEDs here. It actually does work, but for some reason it doesn't light up all of the time. Like, it depends. Sometimes, like, when the pitch is set a certain way, it will light up, or I don't know what it really is. There's not really any rhyme or reason to it that I can wrap my head around, but anyways, I don't want to spend too much time on that. I want to get into all the good stuff about this sequencer because there's got so much coolness to it. Right up here on the left side, we've got like the run and the stop modes here. So we can put it in run, and of course then it runs. You can see it running there and repeating once it gets to the last 12s, the 12th step, and then I can just put stop and it stops. We've got our rate, which is just the speed. I can slow it way down here. I can speed it way up as well too. Pretty cool. Let's leave it sped up. That looks really neat. And down here we've got a run input, and then we have a sync input as well too. So sync is pretty simple. I mean, you can just send like a sync signal from, I don't know, like a drum machine or a sequencer or whatever, you know, a metronome or something, and then you can sync the sequencer on this up with something else. And I've tested it, and it works really, really well. If I recall correctly, I actually got that synced to it was a Korg something or other at one point in time. Korg, not a Poly 6, Poly 61, that was it. Yeah, the Poly 61. Anyways, yeah, so the run input, actually I'm not really sure what that does. I think that might, like if the sequencer stopped, I think if you put like some sort of a pulse in there, that it might start the sequencer. I can't really quite remember, but it's something like that. Anyways, over here we've got a step button, and that's if we just want to advance the sequencer one step at a time without it repeating. Right here you can see we can start it right, well, no, actually, I can't remember what that does, actually. I think it, oh, wait a minute, no, actually, I have no idea what that does. I can't remember. So hopefully somebody out there can answer maybe in the comments what that does. But the load button here, it starts the sequence is what it does. And you can see whenever I plug one of the outputs from one of these sequence steps into this load, what it does is it sends a pulse when it gets to that part, which re-triggers the sequencer to start again. So that's how you get it to loop over and over again. Okay, so for each one of the steps of the sequencer here, we've got these, I think these are like 20 turn pots or something like that. They turn for forever, and that's how you adjust the pitch of the steps right here. So it takes a little bit of time to be able to set up the pitch, but you can do some really super cool stuff with this. You can get into micro tuning, and that's one of the super coolest parts about this. You can do like just the tiniest, most minute pitch adjustments with these. And you can get like some really cool stuff happening depending on the speed that you're set at. And then, you know, like how like your envelope generator is set off of this, or maybe you're sending all of these steps out to various places all over the synthesizer and doing cool things with them, because the voltage varies depending on what the pitch is of this that comes out of each one of these steps. Anyways, it's super cool. This is a really neat section. It's a lot of fun to play with. Very simple, but just a lot of fun to interact with. To the right of that, right over here, we've got the width knob, and what that does is it controls the width of the pulse output from the sequencer. You can see that this is where you get the pulse outputs on that. So that would be if you like wanted to sync the timing from the have something synced from the sequencer, or have this triggering a pulse to something else. So you can see when you look at that LED right there, as I turn the speed down, that'll slow down as well too, because it blinks every time the sequencer advances by one step. And if I turn this knob up, you'll see that the LED stays on for longer. So what that does is it increases the pulse width that gets sent out of the sequencer. So this controls the pulse width of this output right here. It doesn't do anything with this one, because this is just like a little envelope thingamajig that it sends out, just like a little sawtooth, sort of like a pew, pew, pew sort of thing. So it doesn't really do anything with that, or at least I don't think it does. It might adjust that though. I can't frankly remember. And then we've just got our output right here. And so this is the pitch output. So you would normally take this output here, and then you would run that to one of these voltage inputs here for one of the oscillators, or maybe you might run it over here to one of these mults, and then you would take like plug it in there, and then take two of these outputs and run it up to two of the oscillators, or maybe plug that out over here and then plug this one into that oscillator, and then plug that one over here, and then take those two and plug it into these oscillators so that you can get all three oscillators tracking at the same time in unison from the sequencer. Super cool. The knob is for the glide adjustment between the pitch shifts. So remember I was talking about that micro tuning thing? Wow, when you get into some micro tuning over here and then you start sliding this glide knob around here, you're going to be into some serious flavor country in terms of synthesizer tones. This, I just cannot get over, or I can't say enough about this sequencer. It is so much fun and so cool. Okay, so let's move on to something that is, well, you know, it's the balanced modulator. It is a cool module. I don't want it to feel bad, you know, after we just had a real party over here at the 4780 sequencer. But, you know, the old 4710's no slouch either here, the balanced modulator. It's got a carrier signal thingamajig right here. That's where we would put our audio sort of input, if you will. Our carrier signal, and then there's I actually frankly don't really understand a whole lot about this module right here, so I'm not gonna blather on to no end about it right here, but typically these would be your inputs, and then you can, like, you know, mess and modulate with the actual audio frequency right here with this guy right over here, and then you can modulate just the volume of the VCA with these control inputs right here. So although it's called a balanced modulator, this is actually a VCA. And on the other side of the synthesizer, I've got another one of these over there. So this synth has two of these balanced modulator VCAs in total. So, you know, it's a VCA. I'm not going to blather on too long about that. It's pretty neat. It does a good job, and it does exactly what it needs to do. So right over next to that, we've got this watt block. This is the power supply for the synthesizer, or one of them, I should say. There's one right here, and there's two more on the other side of the synthesizer. Not really a whole lot to talk about. For you folks out there that are curious about what's on the inside here, well, we will have a look at it, but it's a linear power supply. And it doesn't supply a whole ton of current, but we've got enough power supply here to power up the whole synth. So, you know, it does what it needs to do. Right over here on the top side and over here, these are mults. So basically just like patch jacks, and they're all passive. They're not active at all whatsoever. And so we've got some audio ones here, and we've got these other ones for the pin connectors as well too, which you might have noticed that these are not the typical 1/8" Eurorack connections on the synthesizer. Some folks go and exchange or upgrade these, or I don't know if upgrade's really the right word, but they swap them out for the more modern sort of 1/8" things, and I didn't want to do that. I kept it totally original. Although I did recap the synthesizer and a bunch of other stuff as well too, but I wanted to keep these because I just thought it was really cool. And this synth, when I got it, it came with all the original cables as well too, so I could actually use them. And they're really hard to find. I don't even know if you can actually buy them out there. I bought a bunch of plugs, and I built a whole bunch of these cables myself, but you know, we'll look into that a little bit more later. But anyways, getting back to it, this is how you can just sort of like mult or like take like one output from something and split it into a couple of different things. Yeah, and then there's just like the power switch right there. So right next to that, oh yeah, by the way, that's the 4770 watt block. Of course, I'm sure you can probably see that on the screen, but hey, what the heck? Maybe I'll just, you know, I'll point it out as well too. So right next to that, over right beside it, we've got the wing module, and this is not a power supply. It's basically just this section right here of the power supply. So it's just mults. It just is splitting signals. Same thing. So it's got some audio splits right here, some of the control voltage splits right here, and these are not splits. This is where you can get access to the grounding of the synthesizer right here, and these are also on those pin connectors. And although you can't see it right now, there is a ground socket on the keyboard, and so when you want to use the keyboard module, you just run a cable up from the ground on the keyboard up here, and that gets everything working real nice. So that's the left side of the synthesizer. Let's go have a look at the other side. Up here in the left-hand corner, we've got this 4730 voltage-controlled filter module over here. It's a multi-mode filter as well, too. It's simple, but boy, oh boy, does this filter ever sound sweet. We've got our input right over here. We've got the low-frequency output, of course, for the low-pass filter. We have a band-pass filter right here, and we also have a high-pass filter over here. And yes, you can use all three of those outputs at the exact same time and send them to various places all over the synthesizer. Really cool. And let's see, right below that, we've got the, well, basically the filter frequency knob right here. You know, not much to say about that. You turn the knob and it turns the frequency that you're adjusting. And right over here, we've got like a high and a low switch. So what that does is it sort of like adjusts the I don't know, like the sensitivity of this, if you will, meaning, or like the frequency range that it covers. So depending on the pitches that you are sending through the synthesizer, you might find that this filter is a little more effective in the high or the low range at manipulating the frequencies. Also depending on whether you're using the low or the band or the high pass outputs on it as well too. Right below that, we have the control voltage inputs so that we can modulate this filter frequency. And this really threw me for a loop when I first got the synthesizer, because this is exactly the same as the oscillators, where the filter will not pass any audio through it unless it has some sort of a control voltage input coming into it as well. So what I typically do is I will send one of the trigger outputs from the keyboard or from the sequencer through an envelope generator, which we'll get to. We have two of them here, and one of the ADSR envelope generators, and then I'll send it out of that over here, and then basically I'm always able to send some sort of a trigger to it so that the filter works. Anyways, it's a super great sounding filter. It really does. It doesn't resonate, I'll say that. Like it kind of will a little bit, but really it sounds wonderful. I really, really, really like it whenever the filter's kind of turned down quite low, actually. It really has like this really nice, like the crossover frequency when it's sort of right around those, I don't know, 400 or 500 hertz range areas. It just sounds really, really nice. I don't know how to say it other than that. It's a great sounding filter. Really, really cool. Got a lot of character to it. Maybe kind of reminds me of, I don't know if any of you folks out there are familiar with this one, but there's this cool filter that, what are they called? Doppler or whatever they are, makes called a WASP filter. And I find it's kind of similar to that almost in a way, just in terms of the way it sounds. And I really like that filter. It's really cool. Okay. So let's keep going here, and let's get into these envelope generators that we spoke about a minute ago. So there's not too much really to say here. I mean, I'm sure if you clicked on this video, you're pretty familiar with what an envelope generator is. We've got our attack, decay, sustain, and release knobs, of course, and we have a, this is kind of a cool thing. We've got a button right here, so we can trigger the envelope generator just by hitting this button. I don't know if you can see those LEDs on there, but the LEDs light up. It's really cool. So you can see like, this is the one that shows the attack, and this is the one that shows the decay and the sustain status. So you can see as soon as I hit it, the attack is set really low right now, so it only comes on for a second. But if I turn that attack up, it actually stays on longer, the LED. It's really cool, eh? I like how you can visually see the envelope generator. So if I turn that, say, down again, and if I turn the sustain all the way down, let's see here. Oh yeah, that's right. Yeah. So if I hold it down, I'm just kind of tinkering here. I guess it just shows me if it's like just the sustain is on or something. I thought maybe it might stay on longer, like if I turn the decay up, but yeah, I don't know. Anyways, I guess I don't have to know everything about the synthesizer. If you're watching this video, you're probably just curious about it. And, you know, sometimes life is full of questions. So there you go. I don't know why it says D on there and why that doesn't really seem to represent what happens with the decay knob. But, hey, you know, mysteries are fun. So there we go. So we can, we've got a control voltage input here to trigger the envelope generator. And that's basically just your envelope input right there. So we would typically send a gate output from the sequencer or the keyboard into this. And let's see over here. Nothing too really exciting to go over here. We've got a constant volume output right here. That is, it's not variable. And then we have another output from the envelope generator, which is variable right here. And then we can, of course, vary the volume of it right there. I'm a big fan of sending, typically if I'm setting up like a basic like monophonic bass sound or something like that, I'll usually take the full volume output and I'll use that to trigger the VCA for just the general envelope shape of the sound, and then I'll use the variable one to send to the filter right here so that I can, you know, manipulate that filter or something like that, right? Anyways, I'm not going to bother going over this module because I've got two of them. This is I've got two of the 4740 envelope generator modules. Really cool. And you know, I'll just take a quick little detour before we go up there, and I'll just say right over here, there's two more of these 4770 watt block power supply modules here. So I'm not going to bother going over those like I did before. They're just the same as the one that's over on the left cabinet. So that brings us up here to the top right corner to the 4711 mixer. This is a 4-input stereo output, very basic mixer with just volume and panning. So you've got your 1, 2, 3, 4 channels, and then we have our right output and our left output. And kind of neat that they're on separate knobs as well too. So although it is technically a stereo mixer, you could also just say that it has 2 buses out. It's pretty cool. And so here we go. We've got our 4 inputs, pretty straightforward. And kind of weird that like the inputs weren't drilled in the right places. I don't think that my friend who was the original owner actually had to drill the holes in the faceplates. I just think that might be from the factory, and it's kind of weird that they were drilled like that, but whatever. Actually, I never really noticed it before, you know? Anyways, yeah, we've basically just got our inputs, and then we're followed by a volume right here. And then we've got our panning control right here, just a pan between the left and the right outputs. And not pretty self-explanatory over here, master volume for the right and the left outputs. Bottom right corner, we've got a multi-purpose module over here, which is basically the last one that we're going to look at, because this 4710 is another balanced modulator VCA, just like the one in the left cabinet. So this is the last unique module I want to look at, and it's a combo. It's a noise output here, and it's also the LFO, so they call it a control oscillator. And the keen ones of you out there might notice that this module looks a little different than the rest of them. Actually, it doesn't even have a model number on it. And the best I can tell why that is I think that this is a 2000 series Paia module, where the rest of these are from the 4000 series. And it's my understanding that Paia did make some model, I don't know, like a model 2700 synthesizer, something like that. Maybe like an older model, or like one that's not quite as nice or something. Anyways, yeah, that's why it looks a little bit different. But it works great, and it sounds awesome. It's got a sweet range for the LFO as well too. The noise generator, I think it's just white noise. I don't think it's pink or brown or blue or rainbow, or I don't even know all the different kinds of colors and noises that are out there. But it just, yeah, it's just like white noise, you know. The regular stuff. And anyways, we've got 3 different ranges we can adjust here with this knob here to change the LFO frequencies. And it's really cool to like change that while you're actually playing the synthesizer, because you get like that wom 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 wom, that kind of thing going on. Really cool. You have a coarse frequency, or like kind of like a, I don't know, if this was the coarse frequency, this would be like the fine adjustment here. And this is a continually variable knob right here, just to like fine tune the LFO frequency. And very similar to the envelope generators where they have 2 outputs, this module does as well. So I guess technically it has kind of 3 outputs really. So it has the audio output for the noise generator, and it has the control voltage outputs as well too. So this one's just full voltage and, well, it says here 5 volts peak to peak. And this one is the variable voltage output right here. And you, of course, you vary that with this continuously variable potentiometer right here. So there you have it, folks. That is both of the cases. We'll just have a quick look at the keyboard here now. Up here in the left-hand corner is that ground connector that I was talking about earlier, that output that we can send to connect the ground for the keyboard up here to the synthesizer up there. And let's look over here in the lower left corner. We've got a glide knob right here, just like the one over on the sequencer as well, too, to glide between the notes. And then we've got the on-off knob right here. Sorry. This is the on-off / glide knob right here. So we just click it on a little bit. And then we can turn that up more to add more glide. We just turn it all the way down before we turn it off to get rid of all of the glide. And this one right here is just the general pitch for the keyboard. So this sets sort of like the nominal pitch of the keyboard. And let's see over here, right beside that, we have our trigger outputs. So these are our gate outs. And so we have like a square or like a pulse. And then we have like a little, I don't know, what do you call that? For whatever reason, I can't remember what the heck that's called. It's just like a little sawtooth pulse output. And then we have our pitch output right here as well too. So typically you would send one of these over to an envelope generator or a VCA, and then you would send this pitch output into the inputs of the oscillators, or you might send this pitch output more likely to one of these mults right here, so you can split the signal and then send it to a couple of oscillators. Or like I said earlier in the video, you could send it to one, then send it to an oscillator, then send it over here to split it, and then send 2 more to those other oscillators, and that sort of thing. Anyways, the keyboard itself is 37 keys. It's split over 3 octaves. And there really isn't a whole heck of a lot more to say other than that about the keyboard. Let's look at all the cables that I have for this synthesizer as well, because they're kind of unique. You know, I haven't really seen this sort of stuff before. So without further ado, let's get started with the interesting cables here. These are the pin cables. And you can see they've got these little pins on the end of them here, and modern synthesizers don't really use these. And these are the original cables with it as well too. There's a whole bunch of the originals, and there are some replacements that I bought, some new ones as well too that I made, like this one. And the connectors are a little bit different, but let's see if I can get a close-up of that so you can kind of hopefully see the difference between those. I don't know if that close-up is going to work or not. Hopefully it does. But this is the original one, and this is the new one right there. Anyways, I've got, I think I've got about 21 of these control voltage cables to patch the different various areas of the synthesizer around, and I've got them all the way from maybe like 4 or 5 inches long all the way up to probably about 24 inches long right over here. And I find 21 of these is a pretty good number. I haven't really run out yet. I've gotten close with some really complex patches, but for the most part, that sort of takes care of the job. Over here are how we patch the audio signals in the synthesizer. So we'll just take a moment to talk about that. The synth uses these pin cables for all of the control voltage signals, and it uses different cables to pass all the audio through the synthesizer. So they are completely separate in the synthesizer, and you don't use the same cables. And it's really neat because you can't accidentally plug something in the wrong place. So here I have some of the original audio cables as well too, which is really cool. There are these ones here, and they've got these really old school plastic black connectors on here. They're really nice. They're really cool. Hopefully, see if I can get a close up here of these. These are these really awesome, sweet connectors. I love these. These are all mono 1/8 inch connectors, or 3.5 millimeter for you metric system folks out there. Yeah, they're just really cool. Really cool. And this is worth noting, pointing out, let's see if I can undo one of these. Ooh, really tight. This is kind of a weird quirk with the synthesizer. There we go. Is you'll see the sleeve is not connected on these. And the reason why is because none of the 1/8 inch audio connections have the grounds wired into the cables, which is really strange, you know, really strange. So what I do when I'm patching the synth is I actually, although it's neat to have these original audio cables, I don't really use them. I use typically these ones I bought from Hosa. These are the same thing. These are 1/8 inch TS, you know, just tip sleeve little audio cables, but they are shielded. They're grounded, and so basically you just get quieter patches if you use these proper audio cables. So, you know, I could have grounded these and used cable, and I did actually rebuild these, but I once again, I just wanted to keep it totally original. And they weren't soldered with the sleeves connected originally, and so I didn't want to do that either. And I will say it is odd, it is strange, but you know what? In actual practical usage, it actually doesn't really add that much noise to the signal. It doesn't really make that much of a difference if you use these ones over here. It just kind of drives my technical brain crazy by not having shielded audio cables, so I tend to use these. But you know, in actuality, once again, yeah, they all work great, and I've got 20 audio cables here, and that seems to handle the bulk of the patching needs for the synth. Once again, I haven't run into these either. I've got them ranging in length from 6 inches, and these ones are about 5 feet, and these are all mono 1/8 inch cables. These 5-foot long ones are really handy for running signals from other synths or whatever into and out of the Paia synthesizer. That's why I have these really long ones. And also to stretch all the way across, because sometimes you need to run a cable from the far left side, like on the sequencer, all the way over to the envelope generator or a VCA or something over on the right cabinet. So that's why I have those. Last but certainly not least, I've got this one last cable here, and this is one I made for the synthesizer. It's a big, long, shielded mono audio cable, and it's pretty simple. It's just got an 1/8 inch Nutric mono connector on here, just an 1/8 inch 3.5 millimeter TS connector on the end, and on this end, it's just got the 1/4 inch equivalent of that right over here. And that's so that I can take the synthesizer and I can plug it into my computer to record with it, or a PA system or an amplifier, speaker or something, just to hear it. So there you go, folks. That's the cables that I use with the Paia Model 4700 synthesizer, and a little bit about how we patch them and how you use them. I'd like to take a few minutes now to talk about what I did for the restoration of this Paia Model 4700 synthesizer. I'll just say in general, I did a very long, very in-depth, very time-consuming restoration of this synthesizer, and it's working pretty darn good now. At least as good as it did whenever it was brand new, and possibly even a little bit better than that. I will say, though, that disclaimer, it still is an old analog modular synthesizer from approximately 1976, and so just keep in mind that this is not a modern synthesizer. The tuning is not nearly as stable. It's got a lot of quirks and a lot of sort of like weird character to it. As well as it's working, it still has a lot of character. Anyways, let's get right into it here. I guess first I'll talk about the power supply section, because that was an enormous undertaking. It really took a long time. Let's get a little closer here. Okay, so if you see these connectors here, that's what I'm talking about. And also those 4 metal rails back there. See, when I first opened up the synthesizer, the modules were all wired directly to those 4 rails back there. And, well, you might be wondering, well, what are those 4 rails back there? Well, that is how it spreads power around the synthesizer. Those are the linear power supply modules back there. You know, there's a couple more over there. And basically, I don't know if you can kind of see in there, but those modules, they hook up to those 4 rails back there. And you can see I put some green tape on there so I'd remember what the voltages were. You can see the top one's the ground, then there's a plus 9 volts, minus 9 volts, and then there's 18 volts on the bottom as well too. So, yeah, some of the modules use 18 volts, like the sequencer. Anyways, yeah, so the power supplies, they connect to those 4 rails, and then that's how it spreads power around the synthesizer, and each one of the modules connects to those rails. But you see, a problem was, like I was saying, the modules were wired directly to the rails, so they were just soldered right there, no connectors or anything, and kind of annoyingly, you know, my apologies to the previous owner, but the cables were really short too, so you couldn't even really pull the modules all the way into the synthesizer. You know, you could only kind of get them out like that, and I couldn't do any work on them like that. And so I removed all the wires, and they were a lot of them. You know, there's like 3 or 4 of them per module, and then there's like all the modules there. So I removed all those first, and then this part was horrible. I removed all of the wiring. I removed all those 4 metal rods and the holders for them. And I just resoldered everything because there was quite a few solder connections that were just not really all that good in there. And I really wanted the power supply to be super solid. So I went in and I just rewired everything so that it was really solid. And then I also replaced the wiring that connects every single module to the power supply rails. And so I upgraded the wiring. All the wiring is brand new here. All that wiring's there, and all this wiring's brand new as well too. And by the way, I'll mention I kept all the original wiring. In fact, I kept all of the original parts for the synthesizer. I have all of them set aside. I like to do that. And then I installed all these sockets here. You know, I would have rather something a little smaller, but I think that's kind of the best I could get my hands on at the time. But anyways, boy oh boy, I'll never forget how long it took to wire all these connectors. It took such a long time. It was horrible wiring them all. I'll never ever want to do that again. But anyways, yeah, it was really worth the work, at least anyways, I'll say that. Because now I can just easily remove the modules or swap them around into different positions and all kinds of cool things now. So a lot of work, but it was really worth it to upgrade that power supply section. Yeah. So I guess while we're in here, let's take a look at that spring reverb tank I mentioned earlier as well too. There it is right there. I don't know if I can see a brand on it or not. It's it's an Accutronics reverb. I doubt you're going to be able to see it in there. You know, it's right up there somewhere. There's the model number. I can't really read it here, so I'll just try and get a good shot of it, and maybe I can read the model number later. Anyways, yeah, there's the spring reverb tank. And I pulled out some of the modules so we can have a closer look at those too. So I've got the 3 oscillators and the reverb module out. Let's have a closer look here at one of the oscillators. So all 3 of these are identical, and here's what I did with those is I replaced all the caps, and I replaced the caps with really nice ones as well too. Let's zoom in here, and hopefully this will focus okay. So I replaced the caps with these super nice Rubicons and Nikon capacitors. I think those are Nikonines. I can't really see here through the camera. There's one there, there's a couple more over there, and there's another one buried down there on each one of these oscillators. These are high life. These are like 10,000 hour or up caps. These are the high temperature ones. Not that it needs it because the inside of this synthesizer doesn't get hot at all, but I just figured, you know, it's not that much more money to just put the really good parts in, so I might as well put the good ones in, so, you know, they won't need to be replaced for a very long time, if ever. Yeah, so I did that. Each one of the oscillators has got 6 caps on the board, and then I replaced a few resistors here or there. Like on this one, you can see there's a little bit of a different resistor there. I think I replaced another one down, I don't know, down there somewhere, something like that. What else we got here? Okay, so we've got some potentiometers for adjustments here. You can adjust the symmetry of the triangle wave. This is sort of stuff that you do during the calibration for each of the oscillators. The range, like the frequency range of it, the pulse width trim, so you can adjust, you know, the symmetry or just like the range of the pulse width controls. There's a sine wave symmetry control right there, and there's some other stuff right there that you use for calibration, really complicated. I'm not going to bother getting into that. And in the middle, we've got a couple of chips here as well too. And so these are voltage controlled oscillators. So I'll just mention that out of the way. That's a little op amp right there. It's a 748. And the synthesizers get just littered with these 748 op amps. It's just got tons of them all over the place here. And just FYI, down the road, those might be something to look into, or those could be a problematic area, I feel like, or maybe even a way to upgrade the synthesizer. I didn't bother. I just left them all in. In fact, one of these oscillators, I think, yeah, this middle one, I actually socketed that 748 because I swapped it out and replaced it with a different variety, which I have no idea what I replaced it with. I can't even remember now. But I tried to swap it out and just see if, you know, it would change the character of the oscillator anymore. And I found it wasn't like an improvement or anything. It was just a little different, and I decided to just keep it original, so I put the original back in. I don't think I can't remember if I changed any 748 op amps anywhere on the synthesizer. Certainly not in the oscillators, at least anyways. Something I did replace, though, is these LM3900N chips. You'll see that each one of these oscillators has one. And those are, if I recall correctly, those are, I think they're like some quad amplifier. Might be a quad timer. I think it's a quad, like a quad op amp, like 4 op amps in one chip or something like that. And I think I swapped all those out because I felt like it would help to make them, all 3 oscillators, more consistent in terms of like their range and their frequency tracking. So that like if you're playing with synced oscillators, or like if they're tuned like an octave or like a certain interval apart from each other while you're playing, that they would track really nicely. And it did seem to make an improvement, so I left those in there, and I socketed them too. So I'm almost positive I still have all the original chips, and I could put the original ones back in if I wanted to. Big fan of socketing chips. It's kind of fun to swap them out, and simple little mods that are not really that destructive. Not much more I can really say about those oscillators, you know. Oh yeah, there's the back side of those sockets right there I mentioned earlier when I was talking about the cables, but I was mistaken. You know, the sleeves on those sockets are wired correctly. Everything's just fine, so just disregard what I said earlier about that. It's still a little odd that the cables it shipped with didn't have the grounds wired on them, or sleeves wired, but yeah, whatever. I digress. I cleaned all the pots, of course. There's the back of those pin connectors. I'll have a bit of a closer look at those. That's kind of neat. Maybe I can see them better over here. Yeah. Yeah, you can see there's just one conductor, and that's it. But they're generally carrying pretty hot signals, like in the, I don't know, 5 to 10 volt range or something like that. So, you know, they seem to be pretty happy. Yeah, so I guess that's pretty much it for the Reverb. Oh, let me just zoom back out here. That's pretty much it for that top row in the left cabinet. Let's have a look at some more modules here now. Let's take a look at the restoration of the bottom row of modules here now. And I guess we'll get started with the sequencer. And boy, oh boy, is this One beefy module here. Just look at that. Those dual layer circuit boards. Ugh, look at that. There's just so much stuff going on there. Boy, oh boy, oh boy. We'll get that out of the way. Woo, sorry. My modules. Just move you back there real nicely. Put you right there. Yeah, so there's an awful lot of stuff going on here. This is one heck of a complicated module. You can see those sweet 20 turn pots right here. So you can see as I turn those, that little red thing right there, which is the wiper of the potentiometer, it moves up and down. And so that is a resistive strip right here, that metal part. And what it does is it basically increases or lowers the resistance here, and then through the wiring, that can change the pitch of this output right here, or this step. And it's really cool. So you just turn that, and then when the red part's all the way on one side, it's like a low frequency. When it's all the way on the other side, it's like a high frequency. It's really cool. Oh, what else is there to look at here? I'll just get this electrical tape out of the way real quick here. I just slapped that on there just to protect the top of the potentiometers here, because where it wires up to the board, or the mount's right up here, you can see that screw hole's right there, and it's very, very close to this metal part right here, and that's grounded as well too. And I didn't want there to be a short between these lugs and that, because they're really, really close to each other. So I didn't think that they would touch, but I just wanted to be on the safe side. So I put a little electrical tape just on those potentiometers there. They're the only pots that are close to that, so I didn't bother with anywhere else. Of course, did some recaps here as well too. Replaced the big filter cap down there. You can see that big fella right there. And I wasn't able to find an axial replacement, so I had to put a radial one in there. So you can see I've got the piece of wire sort of stretched down there to make the gap. But I heat shrinked it, and I used some nice quality wire, and it's pretty good. Worked out pretty nice. There's another little cap down there I replaced as well too. My little pointer or something down there I think I replaced, and there's I think another. Whoops! That's my thing. I think there's another one I replaced in there. Once again, really nice, good quality caps. And let's have a look over this side of the sequencer as well. Bunch of stuff in there, you know. I don't think I really had to do a whole heck of a lot else. I replaced a couple other caps here. Yeah, I kind of think that that's pretty much it. I think I'll just point out real quickly, you might have noticed it earlier on, but one of these LEDs is burned out in the front of this. It's the one for step 2. Unfortunately, it's not working right now. And they're really teeny tiny little LEDs. The reason I didn't fix it is because it's a real pain in the butt. Like, you have to unsolder a ton of wires and a bunch of, and I just couldn't be bothered, frankly, because it just works fine. The step works fine, you know. The LED doesn't light up, so I just said, the heck with it. I just moved on. Yeah, so that's pretty much the sequencer. So let's have a look over here at the 4710, the VCA. And yeah, you know, not a whole heck of a lot to look at there. We got 4 or 5 caps on there that I replaced. 1, 2, 3, 4, 5. I didn't do any resistors on there. We got another one of those 748 op amps right there, and by the way, there was one over here on that sequencer as well too, another 748. We got a whole bunch of these LM3900 chips in there. There's one there, and right there. I have a feeling maybe someday I might upgrade those, or it might be nice to upgrade those or replace them. Because I think those are the same chips I put in the oscillators. But once again, it was just a real pain to swap them out, so I didn't bother. And the sequencer is just working really well, so I didn't bother with that. Yeah, but anyways, let's get back over here to the VCA. We got an LM149. I don't really know what that is, but worth mentioning. And then just a quick, simple little trim pot over there. Not much to talk about on the VCA. Let's look at the power supply. That's a little more exciting. Not really, but you know, But, you know, if you're into power supplies, who knows? Maybe it is. So it's a linear power supply, and I just replaced the two big filter caps at the end of it. You can see right there. Once again, really nice Rubicons went in there. And let's get a close-up of that transformer. Let's zoom right in here. And I'm just going to move my screen out a bit here so I can see better. And it's a little Mouser transformer. And you can see primary 115 volts. And the secondary 12.6 volts at 100 milliamps. And then basically they, there's over here, there is a 4 diodes in a bridge rectifier configuration. And there is, I thought there was another transistor. Is there another transistor in there? No, that's it. It's just like a super simple linear power supply. So basically, yeah, the AC comes in, gets rectified through the, it gets stepped down through the transformer and rectified through the diodes and then smoothed out a little bit through the filter caps, and then it goes through the rest of the synthesizer, and you can see the whole mess of wiring back there just to spread the power around everywhere. But, you know, I put a lot of care and attention into making sure that all the wires were trimmed nicely and wrapped and coiled and all that sort of stuff as well too. And you can see those wires that pass through the front plates. I put little zip tie strips, zap straps, whatever you call those, on there just to make sure that the wires wouldn't tug through there and damage anything and ruin the solder connections in the boards. So that's some safety mechanisms there. What else? Oh yeah, I fused it as well too. Originally for the factory it's not fused, so I put a fuse in here, and I have a feeling that this is like a 1 amp fuse, something like that, because the synth pulls so little current. It's just a teeny tiny little bit of current. I mean, look at that. This transformer's only supplying 100 milliamps, and there's 3 of those in there. So, you know, I think I got maybe a 1 or a 2 amp fuse or something like that in there. Anyway, it's just a little bit of added protection. Didn't have anything before, so yeah. Oh, not really much else to look at on that power supply. I guess I'll just mention that the watt block, the 4770, I've got 3 of those in this synthesizer. So there's one there, there, and there as well too. It's time to have a look at the right cabinet now. So without further ado, let's get right into it. First of all, real quickly, I remember whenever I was redoing all these rails in the back of the synth here, you know, there's 4 of them. There's 2 on the left side and 2 on the right side. I wired some extra connectors on them, just because I think I put 4 connectors on each rail. I think I did, yeah. And there's only 3 modules here, and that's right. So that's what I did, and that's why, because I figured I might want to reposition the modules at some point in time, and I wanted to make sure I had enough power connectors in the future if I ever wanted to move things around. So I installed an extra plug right there. So it's not plugged in anything right now. Nothing's missing. It's just, you know, just to accommodate any future changes I might want to make. Yeah. So I tried to have a little bit of forethought when I did the restoration work. So here we go. This is the VCF here, the voltage controlled filter, and it's pretty cool. It's got all kinds of neat stuff going on in here. So let's have a look and at some of the parts here. So I've got, let's start with the filter caps as well too. We got a couple up there. Once again, those same old Rubicon, really nice ones. And then I got a whole bunch more down here that I replaced as well too. And although I don't know if you can really see, but I used heat shrink tubing on all of the legs here, and I tried to keep the lead lengths as short as I possibly could without things getting too tight and congested in there. But I had to leave them a little on the long side, and that's why I put the heat shrink tubing on there, just to prevent any short circuits. And it worked out pretty nicely. I've got a double stacked pot here for the resonance control, and that's kind of cool. I made sure to clean all those out really well. Got another one of those 3900 chips right here, another 748 op amp, and we got a couple of other what I believe are op amps right here. There's some RCA ones in here. There's a CA3080S544, maybe something like that on it. I don't know. Yeah. And I don't, yeah, did I do any resistors? No. Oh, there's another cap down there I did, way down there. And oh, I don't think I changed that one. I think that's original. And you see we got some of the original transistors in here, and those are gold legs on them. Those are actually pretty nice. Oh yeah, and it's got lots of shielded wiring in here, which is kind of nice to see, because remember those audio cables weren't shielded that we use for patching it, but the internal parts here are shielded. So those must be like really low level audio signals that pass through there. They want to keep the noise away from them. These are, I'm not going to touch those because they're really sensitive. Those are the adjustments for calibrating the filter and setting it up. Yeah, so that's pretty much the filter right there. Let's have a look at one of the envelope generators here. And oh boy, there's not really much I can talk about here, but there is definitely something I want to point out. We got the pots, you know, made sure to clean all those. Got another 3900 right here. We got a couple of transistors. I've replaced a couple of capacitors right here. That's another one. That looks a little different from the others, but I think that's, what brand is that? That's Illinois capacitor, that guy, the blue one. So it's still a really good brand name. And I think it's just what I had on hand as well, too. Interestingly enough, this synthesizer, I didn't put this in here, but it's got a couple of these old carbon, I'll see if I can zoom right in here so you can see that's pretty small. But it's got a couple of those carbon composition resistors in there. And most of them are like these newer style resistors, but they probably had like a whole bunch of those left over at the factory, and they're just trying to clear out some of the old parts, so they just use some of them up. And it's kind of neat to see some of those old guys in here. I didn't put it in there. Oh, what else? So I think that this is worthwhile mentioning. I remember, I'll put a link to it somewhere, maybe in the description, to the website I followed for a guide on restoring one of these synthesizers. And I remember him doing a modification to this module, and I didn't do it to this, but I wanted to, and I just never really seemed to get around to it. Maybe one day I will. But there's something you can ground on this, and then it helps to keep any kind of like a thump or anything happening if you set the attack control really fast. I think it has something to do with like there's something that's floating. This is a little bit beyond my experience level, but there's something floating in here, and if you ground something, like, then it helps, I don't know, just make the timing more accurate or something in the envelope generator. Oh, not an original thing. It was a mod that the guy suggested, and once again, I wanted to keep things as original as possible, so I didn't bother with it, but it sounded interesting, though. I would like to try it someday, you know? Anyways, let's move on. That's just an envelope generator. Nothing too exciting there. There's the mixer. We got all kinds of shielded cable here. Try and keep it as quiet as possible. I replace those caps right here. And when I replace those, just for whatever it's worth, I matched them as best as I could in terms of values as well. The 748s are original. I think replacing these with newer matched ones would probably be a good idea. But once again, it's working great. You know, I didn't bother with it, but that might be something nice to do someday down the road. Cleaned all these pots down here, of course. The mixer works great, and I got my electrical tape trick here as well too, because the lugs for the pots are unfortunately coming out the top side on this module as well too, where, you know, whenever it was built, they should have been flipped around, but I didn't bother doing that. It's just too much work. More than I felt like getting into, at least anyways. And I also wanted to keep it original, right? So there we go. But ideally, they would have looked like these pots here. You see how the lugs are sticking out on the top side? They should be sticking down like that. I think that would have been a better build choice right there. Let's look at the final modules here now. All right, well, I guess it's time to have a look at the last few modules here. And of those, I think there's really only one that we're going to focus in on, because these two over here are just two more power supplies like that one. And they're the same, you know. I've got to replace the filter caps on those and wired new sockets on them, and you know, same transformers, the original transformers, that sort of thing. More zips or zap straps or zip ties or whatever the heck you want to call those, and yeah, that same thing pretty much all around. Oh yeah, that's another envelope generator. So, you know, I'm not going to bother getting into the nitty gritty of that, but same as before, replace the caps, sprayed the pots, you know, calibrated, that sort of stuff. Yeah, let's move on. So here's the noise generator and LFO. And it's interesting. It says on the board oscillator, but technically it is an oscillator. It is oscillating, but it is a low frequency oscillator. And it is the, look at that. You can see it says right there, it's upside down, but it's the 2720 module. So I guess my memory served me correctly earlier when I said that it was a 2700 series module, because yes, indeed, it actually is a 2700 series module. Okay, so replaced a couple of caps on there. You can see there's a big one, a couple of small ones right there, and not much more to look at on here, but I wanted to point out these really cool parts on here. They just look really neat. I can't remember exactly what these are. I kind of think that these are inductors. See those little rainbowy green parts back there? We'll try and focus on that one. Yeah, they're really cool. There's 3 of them on this. And I think that they're inductors. I think that's what they are. They might be capacitors. Or maybe resistors, I did it. But I'm pretty sure they're inductors. Anyways, they're kind of cool. Yeah, not much else to look at there. Just a couple of pots. We got a big wafer switch thingamajigger going on here for the, you know, whenever adjust the different frequency ranges. That's pretty cool. Yeah, and then we got right over beside it, we got another 47, what is that, a 4710? Yeah, that's the, it's just like the balance modulator on the other side of the synthesizer over there. Exactly the same, and you can see all the same restoration work. We got that same 748 down there. We got a bunch of caps up here I replaced. We got one there, another one down there. And we got a couple of pots we can adjust. Another big potentiometer right there. I had to spray out and clean, and yeah. And just have a quick look in the back of it there as well too. You know, there's not much to see back there, but yeah. Oh, you probably want to see what the underside of these modules look like. I'll just lift a couple of them up. I'm not going to look at every single one of them, but you can see that's what the bottom of them looks like right there. Yeah. So after I was done, I'll just mention, after I was completed restoring all of these, I wiped down the bottoms of them with isopropyl alcohol, the 99.9% stuff. Just and I cleaned away all of the for whatever reason I can't remember the name of it right now, but I cleaned away all the leftover rosin from soldering, all the brown guck, and just to make sure that it wouldn't sort of erode away any of the connections or strips or anything like that. So the synthesizer would last a really nice long time. And there you have it, folks. That is the inside of the synth and what I did to the modules. Oh, I also just wanted to mention that when I rewired the power supplies, the synth originally just had a 2-prong unpolarized plug, and I opted to put one of these 3-prong plugs on here just to make sure that everything was properly grounded. Yeah, and that's been working out really nicely. Now, I'm not going to spend too much time on this, but I just wanted to show you the big bag of parts that I kept here. Yeah, you can see that I'm recording this video here in February 2022, and I did the restoration back between September and January from 2018 to 2019. And boy, oh boy, was it ever a big job. If you look in there, you can see a bunch of the original caps and wires, and Oh boy, there's a bunch of stuff in there. Like I said, I kept everything. A bunch of the old. Those are all the original wires that connected all the modules to the power supply rails. You can see there's a little cap down there. And I can't even remember all the stuff that's in there, but there sure is a heck of a lot of it. I'd like to take a look at the inside of the keyboard now. Let's go over here to the power supply section. And I didn't do much restoration work inside this keyboard at all. Actually, I didn't recap it even. I just left the original caps in. And once again, upon testing the original caps, even in the modules for the synthesizer, were actually mostly in pretty good shape, but they were pretty old at that point, you know. They're like, what, 40 years old or something? So I decided, yeah, I might as well replace them. Anyways, I haven't changed these ones out, but the keyboard works fine, so I haven't really bothered with that. You can see that's one of the potentiometers used for tuning it. I'll show you what I did do, though. There's, of course, all the little tuners for every single key has its own little tuning adjustment. And this G sharp note here, I think it was the G sharp or something around there, somewhere around the middle of the keyboard, right around in there. One of the tuners, the trace was worn out on it. It had somehow gotten eaten all the way through. So I replaced that, and I didn't have the original type. I couldn't get that. So, but I did have these this other different type, and it worked just great. And it tunes up no problem, and works just fine and dandy. So, really the only things I did with the keyboard are basically just that part replacement right there, and then I just cleaned it up a little bit, basically. I might have retouched some of the solder points in there just to make sure that they were a real nice shape. But yeah, everything looks original. It's got the original transformer. And I didn't change the plug on this one. We'll get that real quick here. Yeah, it's just the original two-prong, unpolarized. It's not the biggest deal, and you know, it's not the end of the world. If we look way down here, there's the two conductors that come from the power cord, and then they go directly into the primary of the transformer, and there's absolutely zero connection between those two prongs and anything else. So really, it won't actually make that big of a difference, but you know, ideally it will be better to recap this and also put like a 3-prong power cable on here as well too. I just haven't gotten around to it, but once again, it works just great. Here's how the keyboard looks whenever it's all packed up. Just a little bit smaller than an electric guitar case, actually. And it pretty much looks like an electric guitar. Undo these couple of latches here, and then that part lifts up. Oop. And you see the hinges, you can just sort of slide it out like that, sort of a thing. Then set it aside. I usually put this part on top of the synthesizer, and I put my wires in there. Here's how the case looks when it's all packed up. I use my foot there for size, you know. It's not the biggest thing in the world. It's pretty portable. It's got some rubber feet on the bottom of it. Yeah, it's pretty heavy though, I'll say that. It's definitely got some weight to it. So that was an overview of the restoration I did on the Paia Model 4700 synthesizer. It's looking a little messy right now, so I'll put it back together here, and then I'll fire it up, and then we'll play it for a little bit here, and we'll get to hear what the thing sounds like. Oops. Let's put them into there. And out there. filter to the envelope. The envelope. Mixer. Oh yeah. Put it in here. Well, folks, that pretty much wraps it up here at Mears Lab for the Paia Model 4700 analog modular monophonic synthesizer. I really appreciate you watching the video, and if you liked it, I would also really appreciate if you could hit that like button and possibly even consider subscribing to the channel as well too. I like making content like this, and I would like to make more of it in the future as well. With your support, it's always appreciated. Okay, well, I guess it's time to just wrap things up, so I'll say see you later, folks, and I'll catch you next time. Thanks.